I'm Christian. This is Angel. This is Rashawn. And this is Eric. And we are Adaptive Friends. Why are we doing this? Well, as we can see here, the switches already available on the market range from $80 to an astounding $210, which is ridiculous for such a simple device. So what we want to do is make an affordable open source button that anybody can build or modify. Our goal is to improve accessibility and give users more control over their own assistive technology.
The objectives of our assisted switch is to design a large, easy press button for users with limited mobility, integrate Bluetooth for wireless connection, a 3D light, a 3D printable lightweight, low cost using accessible materials. Ensure the design is open source by publishing materials and blueprints online. Test the button's response time, comfortability, and range.
Here we have two different types of buttons we might go with. One is called the convex button, and the other one is called the concave button. One button seems to be more of a best choice for our button because our button is supposed to be meant for people who have limited mobility or strength. The convex button is much more easier to press at all angles. Like if you really wanted to, you could press it using your palm, your fist, or use your fingers. The convex button has a much more natural feeling, which is a reason why it's commonly used for arcade machines, while the convex button is commonly used as elevator buttons and I guess gaming controllers. Here we have two different designs for a shell rubber button. We have the circular shell and a rectangular shell. The circular shell seems to be like the best fit for a button since our button seems to be already circular, while the rectangular shell is also a good choice. The circular shell seems to be the best one because our button is supposed to be able to be attached to any type of surface. Using the decision matrix, we decided to use the convex button with the circular base because it provided much more better durability and comfortability with our button.
All right. So this is our cost analyst and budget overview. We have the quantity, how many we need, and our components here. We have one 3.7 volts lithium battery pouch, a one battery charger module, USB-C, a 3.3 voltage regulator, JST cables, male and female. We have PLA material, which to be specific, around 0.083 kilograms, and a Arduino ESP32. And you can use any ESP32. We specifically just used the Arduino brand of their ESP32, and from that each cost with all this, the total will be around $40 to $50. These are the materials. This is a more visual presentation of the materials. This is the ESP32 board. This is the Arduino one, a lithium battery pouch, the battery charger module, a voltage regulator, the JST cables male to female, and PLA for the 3D printer.
So the button went through many iterations, where a lot of our iterations were done through blueprints, where this is a few of the blueprints that we used. One of the first iterations was with this blueprint on the left here, where we had the top of the button, the switch that held them. This is a mechanical switch, a Cherry MX, a disc, which would connect into the bottom of this, and it would allow for a more flush-looking design. You then have the holder, and then the button holder, and then the button holder for the bottom. And this was our schematic for that design. However, we didn't fully go with this one, and we opted for a different one. However, we also drew out what it would look like all together, and that would be on the right there, where you can see on the top button look there, that would be how it's all together. You can see a large dome and a base where all the components, the insides would go. There's also another one on the below that, which states how it will look.
Here we have three different types of prototypes that we have here. The first prototype was very ambitious for us, but ultimately it's probably the hardest one that we can work with. Here we can see that we were initially planning on connecting this piece along with this button, and as you can see, there's an on and off switch. So we're initially thinking of like possibly turning it off and on, but like I said, it was too ambitious for us, so we have to make it a bit more simplistic for us to work with. So here, this is where we go to the second prototype. We added a switch. So whenever you press down, you will hear a clicking sound. So that will pretty much tell you that the button has been fully pressed down. But since, as you can see here, it currently looks too small, we then decided to combine all the ideas we had with the first two prototypes into the third one. Where here in the third one, you can see that there's much more. That here is where the switch will go, and here is where all the electrical components for what our button will be stored. And then here is where the actual button, whenever you press down, you will hear the click, which is this is where the switch will be at.
So this showcases our final prototype, and where you can see from the last slide, this is exactly the same image. We have the button cap, the switch housing, which has the switch holding inside there. The switch then connects through wires down into here, which includes the ESP, voltage regulator, and all the other ones that we listed in previous slides. We created a schematic with all the numbers and models that we will need for our button. And the button is made for its ergonomic comfort, where you can press just about anywhere on the button and will activate the button and its function. There's also the internal layout, which is described in all of these. And this is the final design. We also had to do a sim scale, which sim scale is a model program that allows you to measure how much stress the button is, or the object is under stress. And in this case, we did a force of about 50 newtons, which is modeled through the red in the center there. It was a 50 Newton press from the middle of the button down, and a normal button press by average standards is about 5 newtons. 50 newtons is about 10 times that amount. If it can handle that, it can handle any other press that you were to give it, and it can last a lot longer. Because we have proved that it can last with about 10 times its normal press strength, then we have proved that its durability is strong enough to last for just as long as the customer needs.
For this project, we had a few challenges. Like, for example, the button would wobble when pressing it from different angles, and the clicking sounds were inconsistent as the top was a little too heavy for the actual switch to press it back up. And the internal parts were, I don't know, they wouldn't fit properly at first because some 3D modeling issues. But we were able to get that down. Also, we didn't have much electrical wiring experience, so it was a little hard finding how to connect all this together.
During the making of this button, we've learned quite a few lessons in designing and managing our team, where a couple of the main ones were tolerances, where a lot of the designs that we printed didn't have the right tolerances because we didn't account for that in the 3D printing process. We've learned that and we've overcome that with our future designs. Team communication was also a difficult one, where not everyone can be on the same page. People have their lives, different things they're doing, and just being all together as one unit for human beings is kind of difficult. So throughout our process, we did improve and become better at doing so. And with the many prototypes that we made, each prototype allowed us to refine our design and make it better each time, and made the future ones just that much better.
In conclusion, we were able to create a detailed 3D model design of the assistive button while focusing on making it comfortable, accessible, and easy to use. We also designed on the bottom space, we designed a little spot for each individual component just for easy accessibility. And so the components don't just like move around. We identified some areas to improve, such as stability and button response, so you can give out the best experience for the user. And that was our project. Thank you for watching.